Hello everyone, welcome back to another video. My name is Jubin, and in this episode 9 of Azure Databricks series, we are going to look at machine learning on Azure Databricks using MLflow, and this is what it turns your notebooks into real ML workflow, not just one-off experiment. So we will track experiments, look at tracking the experiment, registering the model, deploy with confidence, and but before that, what is MLflow? It's an open source platform for managing machine learning lifecycle. It helps data scientists and ML engineers keep track of the experiment, package the model, and deploy them. So think of it like a Git project management for GitHub plus or Git version control plus project management for ML models. And what problem does MLflow solve? So when training the model, you might try many combination. Model tree has 100 trees, which gives 89% accuracy. Model B has 200 trees, it gives 91% accuracy. Model C has different features, so it gives 93% accuracy. And without MLflow, it becomes very difficult to remember which code produced what model, what parameters were used, what data set was used, what model performed the best. So MLflow automatically records this information. So MLflow has four main parts. First part is the tracking. So you have log parameters, metrics, and results for every training run. So you never lose track of what settings are producing which result. And then you have models themselves. So any model can be loaded and used consistently, no matter how it was built and which library created it. And then you have model registry, which we will look at in more detail in a bit. So it's a central place where you can version and manage your models as they move from testing to production. So think of it as a version control specifically for models. And then finally, the deployment. So it serves as a registered model behind an endpoint. So it's ready for real requests without you having to build and serve, without you having to build serving infrastructure yourself. Here is the typical machine learning life cycle. You have training data, you train the model, MLflow experiment tracking, you compare the runs, and then you select the best model, and then you have the model registry, and then you deploy it to production, and then you have your batch predictions and real-time API. And then this is the same thing in general and same thing in Databricks terminology. So step one is you have your delta table. Then you train your model using data frame or Spark skills from earlier episodes. Uh, and you log with MLflow with capturing its parameters and matrix. This happens automatically once you call MLflow functions. Step three is once you're happy with the model, you register it. You make it as a real candidate for use. So that's what the model registry does. And step four is deploying the model. So it can serve real predictions on an application to the user. And last is the prediction. So you have your batch and real-time predictions. So we are going to look at this pipeline for data into the Databricks today. And we are going to do it in our demo, and we are going to build an actual machine learning model and from our data set. So and create the features and also deploy the model and run the experiment. So every model you build can follows the same path, whether it's a quick experiment or needs something that's headed to production. MLflow gives you two different tools and it helps you know when to use which. So first one is experiment tracking. It logs every run while you are testing different ideas. Nothing gets lost, even the runs that don't work out. It lets you compare the parameters and matrix side by side so you can see exactly what's changed between the attempts and helps you find your best performing run without digging through scattered notebooks or spreadsheets. And then model registry is the second. So holds your best model with a clear version number. When once you've decided it's worth keeping, uh, it holds your best model. And then tracks its stage. So it either it's staging or production. So everyone knows what's actually live, what is being tested, and it acts as a single source of truth for during the time of deployment. So avoiding confusion when that business model is the real one. So now looking at the demo, we'll go to our workspace. We'll launch the workspace. You can easily go to portal.azure.com if you have been following this series, and then you create your Azure workspace and launch the workspace. Now we're going to a new notebook, and so I'm going to name this is episode 9 MLflow notebook, and going to close this because I was trying few things out for confusion, to avoid any confusion. And then, so first thing is that we are going to load the data, and this is in Python. And now we are going to use our PySpark to create a data frame from the orders table. So we are going to create a new column, which is called is high value, using our orders table. And we are going to look, and that table is created based on the amount. If it's greater than 50, then it will be marked as 1, otherwise it will be marked as 0. And then we are going to convert the, so this is step 1. In step 2, we're going to convert the categorical status column into numerical feature and assemble the feature vector that Spark ML needs. So I'm also going to share this notebook after the video. So first one is the input as a status column and output is the status index. And then we are going to use the vector assembler to create the features column. So we will see all of that in a moment, but let me also show you how this column looks like. So df dot display. So we'll see what column it created. And then we are also going to run this. So you look at the amount is less than 150, so it's marked 0. It's more than 150, so it's marked 370. And there are 53 such rows that are marked. So 168, 141 is marked as 0 because it's less than 150, and so on. So this is the new is high value. So we are just marking a customer whether they are high value customer or not. And then we created so we updated our data frame. So let's look at what this looks like. Okay, so I was already experimenting this and I have already created the status index column. So let's look at our data frame again. All right. So once you run this, it's giving me an error because I already ran this command. But once you run this command, you will see that a status index column will be created, and it is just going to create based on the string indexer, and then based on it, it's going to create a features column. So next is we are going to split this data into training and testing. So we are going to create two data sets, train DF and test DF, and with the 80-20 split. So 80% of the data becomes training data, 20% becomes a test data, and then there is a seed of 42. So we always have it. So it's randomized, but we also always have predictable training and test set. And I'm going to do display just to show you what this data frame looks like, and test TF to show what this data frame looks like. So 41 rows here and 12 rows here. And now we're going to train inside MLflow and log everything. So I'm going to remove these extra spaces. I'm expecting some error, but let's see. So we have an indentation error here. Good. Okay, so we have logged one MLflow run. And then yes, so this is the error that I was expecting regarding volumes. We might need to create additional volume. So I'm going to create a Unity catalog because I need the schema, the volumes that we have in the demo workspace. And then we do not have any rows. So we are going to create a default MLflow volume. So once that's created, let's see, run this command again. I'm just going to comment to make sure you're following with me, is view the volumes for MLflow in Unity catalog. And then we are going to create a MLflow volume for storing our model. And then once that's created, we now remove this cell. And then over here, we are just adding the OS into our environment. And then let's run this. And now let's run this step. So we are logging one MLflow step here. Okay. So this run got successful, and we should see the accuracy somewhere. Let's see. Predictions. So these are just warnings but I want to see the some. Let's see, print the accuracy. So it's 66%. And Databricks displays the value. And let's see, we have predictions. So is high value, so it's predicting the probability on every value. And this is the high value, and it is probability is 45 to 54. Okay, so now we will go to the experiments tab on the left pane in the sidebar. So under the AI ML section, go to experiments and select the most recent experiment. So this is my most recent experiment, and it automatically says that we have detected the experiment type to be machine learning. You can either confirm or change the type. So I'll just confirm that it is a machine learning experiment, which it is indeed. And this is the most recent run which got successful. We tried couple of attempts, and now I will click here, and so I'll probably rename this run as uh, orders high value classifier demo, because this was the most recent run. I will click on this, and I can see the run ID. I can see the source. So the source was this notebook that we just built, and I can add a description for this. I don't want to do that now, but I can see the model matrix, system matrix, traces, artifacts, and yeah, so this is the run that is registered now. And and when yeah, and it also shows the workbook in a nice format over here that we can reference later. And now we are going to register this model. So it says that the model register is invalid. So let's try one more time fixing our model, because in the Unity catalog model registry, it mandates a signature, which we don't have. So we will go back to our step, and we don't want all these suggestions before and after. We'll exit this, and I'm going to create a new block here and call it updated Unity catalog register. Okay, so seems like the task 5 out of 5 task ran. It is still running. And we can see the latest runs over here. Okay, perfect. Now we can see the input example. We can see the predictions, sample input, sample PD. So let's go and try to register this one. So we will rename this as orders high value classifier. Demo 2. We will save this. And now we have similar thing. So we are going to register the model. And now the Unity catalog doesn't give any error. So now let's see, select an existing model or enter a model name. So I'm going to enter a model name, orders high value classifier, demo 2. And so I'm going to put demo workspace default orders. So because this is not an error, this is just how the naming is required. And now it's trying to register the model. Okay, started registration on this ID, which is the same run ID. And please be aware this process may take some time. We recommend actively monitoring the registration process. Okay, so this is how we successfully registered a model. And now that's it for this demo. And we quick recap, model flow tracks every experiment, so you never have to lose a good result, even the ones you didn't end up using. A model registry gives every model a version and a stage, so there is no confusion about what's live. The full cycle is you train a model, you log, you register, you deploy, and that's a repeatable pattern for every model you build. And that's it for this tutorial. Thank you so much for watching. If you have enjoyed, please like and subscribe. It really helps the series reach more people. And in the next video, we bring together one more final project using everything. Uh, it's going to be a very interesting one using the medallion architecture. So stay tuned and see you in that final project. Take care.